in the jar estimation activity, I had you explore this whole concept of volume and what it means. We are going to take a little further look at what it means to take up space and what that means for volume, but we're also going to look at how to calculate it for regular and irregular shapes. Chapter 14 also includes mass and temperature. Those will not be as great of a focus for us. We're going to focus more on volume. So you'll be able to calculate these, like I said, but then we're also going to take a look at how to convert units of volume. So like we did with linear and square units, converting between meters and centimeters or inches to yards, we're going to do that with volume as well. Then we're going to take a look at ratios of similar figures and what that means and how they compare to one another. And that's going to be our primary focus for chapter 14. So first of all, take a look at this two different constructions. Pause the video here and calculate the volume and the surface area for each. All right, in that first image, the volume is 9 cubic units because we literally have 9 cubes. And in the second image, I hope you could see that we just moved that blue cube over one, so we still also have 9 cubic units. But what's different is the surface area. So if we literally counted all of the squares that were exposed, in that first one, there would be 34 exposed faces. Now, by moving this blue cube over one, we have exposed 2 more faces, so therefore we have 36 square units for our surface area. So something can contain the same volume, but it can have a different surface area, just like you're going to do with your final project. All right, let's think about the formula for how to calculate volume. Hopefully you saw in either the jar exploration where I had you look at the bottom layer of the Reese's Puffs so you could actually count if you wanted to and then see how many layers were in the jar and multiply by that to make an estimate. Or if we take a look at the dimes in the next examples that you have there, you're looking at how many dimes you have, finding the area of each, and then multiplying it by how many there are, because that's really just the height of it. So what we do is we find the area of the base, so we take length times width, and then we have to think about, well, how many layers would there be? There would be h, or however tall it is. That is why our volume is length times width times height. Now, like I said, to be able to convert, it's just like we did with square and linear measures. So if I have 1 meter cubed, it's a 1 by 1 by 1 cube, but then the centimeter equivalent would be 100 by 100 by 100, or 100 to the third power. That's where I'm getting this 1 million. We're going to take a look at an example, and I think it'll help you understand it a little bit better. So here we go. If I have 5 meters cubed, I want to know how many centimeters cubed that is. So I think about, well, in 1 meter cubed, I would have 100 cubed centimeters cubed. We have to take it to the third power because we're talking about volume. But I don't just have 1 meter cubed. I have 5 of them. So I have to take 5 times this number, 5 times 1 million, if we want to write it out in standard form. That's where I'm getting that 5 million centimeters cubed. All right, let's think about this next one. I'm going to write this one as rates like we did for linear and square measure. I think that'll help us understand it a little bit. So if I have 12,300 millimeters cubed, I have to think about, well, how many centimeters are equivalent to a millimeter? And I've got 12,300 millimeters, and then I'm going to take it, and notice I've put millimeters in the numerator and the denominator, so they reduce one another. And 1 centimeter is equivalent to 10 millimeters. Now, since I'm talking about volume, I did cube both of them. So I have to take 12,300 divided by, or times 1, divided by 10 to the third power. What do we get? We get 12.3 centimeters cubed. In this next one, we have an English example. So we're talking about yards and we're converting to feet. So we have to think about, well, how many feet are in a yard? And again, I'm going to write this out in the unit rate form. So I currently have 45 yards cubed. Well, I want yards in the denominator, so they reduce one another. Well, 1 yard is equivalent to 3 feet. Since I'm talking about volume, I'm cubing all of my units, all of my numeric values for this. So I would take 45 times 3 to the third. 3 to the third is 27 if you want to do it separately. And we get 1,215 feet cubed. Okay, hopefully you're understanding this. Pause the video and try these next two, or try the next one on your own. Hopefully you got 1/10 of a yard cubed. If not, we'll talk about that more when we meet in person. This next one is an example of where we're actually looking at mass compared to volume. Like I said, that's not going to be the focus, but if we wanted to, we could figure out how many gallons there are in a foot cubed, or in this case, 10 gallons in a foot cubed. But like I said, don't worry about having to know that one. Okay, Cavalier's principle is just this. If you take the volume of a shape, for example, on the left there, letter A, and you just bend it a little bit, or you bend it a little bit more like in C, you're not going to change the volume. Think about like a stack of dimes. If you had a stack of dimes like in that example you did, and we just scooched it over and made it a slanted stack of dimes, well, it's still taking up the same amount of space. It just looks different, right? So the surface area might be different, but the volume remains the same. All right, let's take a look at a pyramid and a cone. I put these two together because they're similar. Now, don't start writing yet. I want you to just listen. A cone literally holds 1/3 of the space that a cylinder does. So for a cylinder, we knew we would take pi r squared, because that's the base, times the height. Well, now a cone, we're just multiplying by 1/3 out front because it's 1/3 of that space. Similar, a pyramid with the same base as a right prism holds 1/3 of the amount of space. So to find this, we took length times width to get the base area, the orange area, and we multiplied it by height. So to do the pyramid, it's just 1/3 of that same exact formula. Go ahead, write those down. All right, now this one's a little bit different. The volume of a sphere is 4/3 pi r cubed. Pi r cubed. Now this is a little bit different because if you remember, we had r squared for the cone times height. Well, the height of a sphere, we're talking about that radius, that is half of our height, but it has to do with this whole idea of 4/3. So for now, just write down 4/3 pi r cubed, and we're going to use that to solve some problems. All right, let's take a look at these examples. If you feel pretty confident in the formulas, I recommend just pausing the video, working through, and then checking a little bit at the end. Okay, for this right square pyramid, we would take 1/3, because it's a pyramid, times the area of this right prism. So the base, my length times my width, is 4/4. The height is 5. So 1/3 times 4/4 times 5, we get a volume of 26.67 centimeters cubed, because we're talking about volume, which is 3 dimensions. Okay, now this cone, be careful. I'm guessing that I might have caught you on this one if you went ahead and worked through these. Notice 10 centimeters is the slant height of the cone, not the actual height. So first, we have to calculate the height. Well, how do we do that? Good thing we learned the Pythagorean theorem. We got a right triangle there. 10 is the hypotenuse, so that would be C. I'm going to say 6 is letter A, and then we're solving for our height, or letter B. When we do this, we should get 8 centimeters for the height. Once we've done this, now we can go ahead back to our cone formula. So it'd be 1/3 times the base, which is a circle. So times pi r squared, in this case 6 squared, and then times our height that we just got, which is 8. Go ahead, calculate that out. We should get about 301.59 centimeters cubed. Notice on this last one, I don't even have a picture. Like, it's a sphere, the radius is 6, that's all we really need to know. So we use our formula, 4/3 pi r cubed. In this case, the radius is 6. Calculating that out, we get approximately 904.78 centimeters cubed. We're going to take a look at what it means to be similar figures and then what that means for their volume. And we're also going to take a look at surface area. But I'm going to save this and we're going to talk about this in class on Thursday.